All right, solving problems with complex solutions. So we have three examples here of problems that we're trying to solve. Perhaps these are figures and we're trying to find the solutions to them. So the first thing we're going to do is see if perhaps there is anything we can do to solve the problem beforehand. And there really isn't a whole lot we can do with this one. We might be able to take out a number, a 6, a 3. Maybe they're both divisible by 3, so we could do that. So let's go ahead and do that. So divide by 3. So 3 times x squared plus 16 equals 0. So this becomes a problem because the x squared plus 16 is not the difference of two perfect squares. It's the sum of two perfect squares, and we don't have a special sort of breakdown method for that. So 3 equals 0 is not true, so 3 is not a factor. And then x squared plus 16 equals 0. So then I have to isolate the x squared, and then what's going to happen here is that I end up having to square root both sides, and we end up with a negative under the radical. So most of the time this would be a huge problem. But for us, since we're super duper smarty pantses and we've already dealt with the negative before, we know what we need to do. So we're going to rewrite this as I times 16, and we're going to break down our 16. 4 times 4, 2 times 2, and we end up with two perfect squares. So x equals plus or minus, we have our I, and then we have 2 squared times, and then we have 2 squared. Whoa, that's a giant 2. Let's fix that. Okay. And so, again, in my mind, I'm saying I is the negative 1, so it has to come out. And then this 2 is going to come out, and that 2 is going to come out, because those are perfect squares. So I get x equals plus or minus I times 2 times 2, which I can simplify to plus or minus 4i. Okay, so there's your answer for the first example, plus or minus 4i. We're going to take the second example, and we're going to do the same thing. Okay, we're going to divide out the negative 5, and that's going to give me x squared, and then it's going to give me positive 30 equals 0. And again, that negative 5 does not equal 0 as a factor, so we're done. X squared plus 30 equals 0. Move the 30 to the other side. X squared equals negative 30. And then we're just going to square root both sides of the equation. So x is going to equal plus or minus the square root of negative 1 times 30. Let's break down our 30. 2 and 15, 3 and 5. That's going to tell me that there are no perfect squares under the radical. So I have negative 1 times 2 times 3 times 5, right? And I can't do anything with 2 times 3 times 5, so I might as well just leave that as 30, since I can't break it apart, but I can take this out as my I. So I'm going to have x equals plus or minus I square roots of 30. Okay? Last problem. Divide out your 2. So 4x squared plus 1 equals 0. Again, 2 equals 0 is not true, so it cancels. 4x squared plus 1 equals 0. Move that 1 to the other side. 4x squared equals negative 1. And before you square root everything, you need to divide by that 4. Okay? So you get x squared equals negative 1/4, and you're going to square root both sides. Okay? X equals plus or minus the square root of negative 1 times 1/4. And so you have to ask yourself if these are perfect squares. And they are. The square root of 1 is 1. So I'm actually thinking about it like this. The square root of negative 1 times the square root of 1 over the square root of 4. I'm literally square rooting every little thing that there is there. This is my I. The square root of 1 is 1, and the square root of 4 is 2. So I get x equals plus or minus I times 1/2. Okay, so a lot of times you're going to see that written as, you can see it written two ways. You can see it as plus or minus 1/2 I, and then sometimes you'll see it written as plus or minus I over 2. They mean the same thing. This is usually the way you see it written, but they do mean the same thing because you could assume that there's a 1 in here in front of the I, and that's where the 1/2 comes in. So same thing. That is solving problems with complex solutions.